Okay, everybody, so this video is about partial model validation. So basically the idea behind partial model validation is that you can take a full model which has stocks, flows, a bunch of variables, put one more stock here, and oops, sorry, we cannot have one to the stock here. So let's say the two are connected. But for some reason, and I'll mention a few reasons later, you want to validate just one section of this model. Let's say just this. So basically, this is the idea behind partial model validation. So, as the name says, you're just validating a portion of your model. Now, why would you like to do that? Well, there are many different reasons. You know, one reason has to do with model validation, meaning uh, you validate one sector of the model if you have data on that sector to know exactly how that sector behaves. So the classical example is the example from classical paper from Jack Homer, uh, where he had a gigantic model evaluating how cardiac pacemakers were being adopted over time. Uh, but then, within one section of his model, he basically had some very interesting, actually fascinating findings to show that publications about pacemakers were oscillating. Okay, so basically what he did was he had some information, he collected some information on not citation, publication patterns over time for these pacemakers, and this was a sector of his model. And then, he wanted to validate just that sector to see whether that sector behaved in accordance to what he found from the literature. Okay, so basically this is the rationale. Now, let's take a look at how actually you can do this. What I'm going to do here is to use a model from the Vensim library. We've actually used this in another video, but this is the so-called yeast model. I'm just going to open this up. Now, you can read more about this model later, but I'm just going to give you a very, very quick overview. Basically, the idea is that you have, yeasts uh, in a lab, and then, they have a certain rate of division, and they die at a certain rate. Now, in the simplified model, and this is the yeast 1 model, what you do is that once you run the model, I just ran it, uh, and then you plot the yeast count, you will get, there's a blue line here, but you will get an exponential growth without any termination. Okay, so it grows exponentially. Now, if you look at this model, the reason why yeasts are growing non-stop is because there's no connection with, water or sugar. Okay? Actually, I just recalled, we did not have a video for this. This was a topic for one of our workshops. Anyhow, so, no, but this is the simplest model. Now, if you want to do something that's, more um, complicated, then what you can do is to take the yeast model. I'll take a more, the most complex model that's provided for yeast in Vensim, and this is the yeast 4. Now, in yeast 4, the model is substantially expanded in that it takes sugar, water into account. So, as the yeast is growing, sugar is being consumed. It also needs water. And if you run this entire model, which I'm doing right now, and then you plot yeast growth, you have something that looks like this. Now, we won't go over the details of the model, but initially it has an exponential growth, and then it hits like a limit in terms of water and sugar that's available for growth, and then it starts declining until the number of these reach close to zero or zero. Now the question then becomes, let's say that at one point you have this specific model, the complete model, but you would like to make a partial model validation of to see whether after you have implemented everything, if the unbounded model, in other words, whether the first model, which had east only without the limits or the boundaries imposed by sugar and water, whether it's still working. Okay, so again, this is a simplified thing. Uh, Basically, what you could do in this scenario is to create a partial model validation, which you can do very simply by doing this. You select each one of the variables that you want to include in the model, and you do that by selecting them and then holding the Shift key. So I'm holding Shift right now, and I'm selecting division rate, termination rate, average lifetime, which is a variable that goes into termination and was in that original model, and then also the division rate. Now I only want this, okay? I don't want anything else. Then what you do is that you go to model, you see partial model. It's getting out of my, I'm just going to push this to the side. So model, partial model, and then I select the option selected variable. Now I'm not going to go over this now, but incomplete model is when you delete certain variables. Invisible variables is basically when you have multiple views, so you have multiple layers in the model. But for now, let's just do selected variable. Okay. I'm going to call this version run. I'm going to call this partial model. Let's bring this back to the. Oh, I can't bring it back. Well, anyway, so I'm going to call this partial model, and I am going to now simulate. A little error. Let me just put this back in here. And now I'm going to plot east count again. And what I find in my east count is that I have a curve that goes back to what I had in the first model. So bottom line message here is, even though I have a full model at this point, I can still select the variables for my simple model and run a partial model simulation. Now, you might ask, okay, Ricardo, so, what exactly happens to the other variables? What about everything else? Well, all of those variables in the partial model simulation, they're held at their initial value. So whatever you have set as the initial value, this is where they are going to be. So, if you had sugar at a certain amount, they will stick at that value, for the time of the model. That's it for now. I think later we're probably going to be coming back to this subject with some other things. Bye.